All right, here we go.
Yeah, I know.
Hello, my name is JD Stucker, and thank you all for coming and tuning in today to our webinar. This is the Ohio Department of Natural Resources Division of Geological Survey Rock Talk on caves and karst in Ohio. So thank you all again for being here. As many of you probably know, 2021 is the International Year of Cave and Karst. So stay tuned for future content on our social media pages and our website for future karst related information as the year progresses. But a couple little things here as we progress through this talk. You might notice the Q&A box over on the right side of your screen, so I'd encourage you to put in any questions that you have there, and our speakers will get to them when they're able. With that being said, I would like to introduce our speakers today. We have Douglas Aden. Douglas Aden has been a geologist with the Geological Survey for about 10 years now, studying caves and karst. We have Brittany Perrick, who has been with the survey about 7 years, also doing karst data processing and outreach work. And then we have Chuck Salmons, who's been with the survey for a number of years, handling our publications and outreach efforts, and he'll be producing and helping field questions behind the scenes today. So with that being said, I'll go ahead and let Douglas and Brittany kick things off, and we can all sit back and learn a little bit about karst and caves in Ohio.
Thanks, JD. I'll try to share my screen here. All right, and can you see that? Okay, so today we're going to talk about caves and karst in Ohio, and we'll just jump right into it. So a quick overview of what we're going to talk about today. We're going to talk about what is karst, what are some of the hazards that karst poses in Ohio. We'll talk a little bit about the different parts of the state or the regions and how sinkholes vary in different parts of the state. And then we're going to switch over to Brittany, and she's going to talk about how we find sinkholes in Ohio, some of the ways we process through data to locate these features, our methods for field verification, how we find them in the field, and also our new interactive map. Let's start out here. We have this lovely diagram depicting sinkholes and kind of how they're related to the water table. So you have sinkholes up on the top. In some places that water, like a stream, for example, can become what's called a disappearing stream, can drain into the subsurface, potentially into a cave. If it's a very active area, this is somewhat less common. And then when that water reemerges out at the surface, you have a spring. So as far as how karst forms, just in a quick summary here, basically you have rainwater, and as it falls through the air, it picks up a little bit of carbon dioxide from the air. It also picks up some acids from the soil. It percolates down through pre-existing cracks in the rock, and over time it slowly dissolves out these cracks in the rock, and they continue widening, and if they get big enough, you can actually get a sinkhole at the surface. So a sinkhole is really just where your surface material is eroding down into these cracks in the rock. Now, if this process continues, you can get some very large voids and eventually caves below a sinkhole. So karst terrain, as far as what the term karst means, that a karst region would be an area that contains features like sinkholes, caves, and springs. Sinkholes are by far the most common feature that we map in the state. And sinkholes, again, drain into cracks or fractures in the bedrock. So as this rock, here's a nice picture showing some of the fractures in a large exposed face. You know, you can see in cases like this, we just have all these tiny little cracks and holes in the rocks. And there are sinkholes that can form in areas like this. So there's not always these large voids below the surface. It's more like a sponge with lots of little holes in it. So most of our sinkholes form in carbonates. So that's two types of rocks, the limestone and I put dolomite. It's really dull stones. Dolomite is the mineral. And also you get sinkholes when there are evaporites, such as gypsum or salt. And another nice hole dissolved right out of the limestone in this photo on the bottom left. So some of the hazards that karst can pose in Ohio. One big problem is, people see a hole in the ground, and unfortunately sometimes they like to fill it with trash. This is actually a trash pile that was burned in a sinkhole. And this is a big problem because a sinkhole is a direct connection to your water table. So whatever is going down into a sinkhole is not being filtered by the normal layer of topsoil and other clays and more resistant layers at the top, and it's going straight down potentially into your drinking water. You can also have problems in Ohio. This is up in northern Ohio in Bellevue, where if it rains too much, the water table can overflow a sinkhole. This is a large sinkhole, and it looks like a lake or a pond, and it causes very severe flooding up there. We'll talk about Bellevue more later. It can also cause problems with infrastructure. We've got a sinkhole here. It's been filled with gravel, but you can see it's starting to crack and affect the road. Again, groundwater contamination, lots of unfortunate things we've found in sinkholes. Another sinkhole here that's getting close to the road. This is relatively uncommon in the state, but we do definitely see this, and we try to keep ODOT appraised of things like this. Another unfortunate trash pile. EPA does some cleanups on tire piles. Not good for the water. Urban development can also be a problem. If all the trees and brush get cut down around the sinkhole, often that leads to some pretty good erosion. So that can pose a problem. It's better to leave sinkholes undisturbed if possible, and any way you can reduce the amount of water draining into a sinkhole can help. For example, here, if you were to build like a small berm or just like a hill of earth around the edge of this, it might keep it a little drier. It might keep it from sinking quite as much. I got a couple series of photos through time as far as development goes. This was one we visited in 2011, just kind of a standard sinkhole here. Back in 3 years later, we've got a couple houses sort of just up the hill from it, collecting some trash. And later that same year, we went back and they had filled it in with large riprap. So it'd be interesting to get back there again and see, how this has held up and if it has continued to sink. Dramatic picture of a microbus in a sinkhole. This was way out in the middle of the woods. I do not know how they got that vehicle out there with some dedication. This is one of my favorite series of photos in southern Ohio. So the first two pictures on the left are the same sinkhole. You can see the water drains down here under a road that's at the top. And then the middle picture, right in the center of the photo, you can see a sort of a large raft of woody, sticks and leaves. And we went back after a big flood event, maybe less than a year later, I believe, and that entire raft of material is gone. So like the rock on the bottom right photo is the same as the rock in the center photo, that big white rock. So you can see just in very little time, there's been a lot of change to this feature. The whole gravel bar there on the right is gone. A lot of material has washed down. So erosion is really taking effect here quickly. So start to talk a little bit about where you see sinkholes in Ohio. There are many things that control where sinkholes are found in Ohio. One of the main things is the bedrock geology. So the map on the left here shows the bedrock geology of the state, and it's very colorful. But the takeaway is that most of the sinkholes kind of form in this trend running north to south along the center of the state, along our thick limestones and dolostones, and then also sort of down near Cincinnati and some of the thinner limestones down there. So wherever we see those two types of rock, that's a good indicator for a place where we might look for a sinkhole. But another important factor, this map on the right shows drift thickness. So this is the thickness of how much material is burying the bedrock. So, you may have a limestone, but if it's, 100 feet below glacial material, which is resistant to sinkholes as it gets thicker, you won't see sinkholes. So just north of Springfield there, I don't know if you folks can see my mouse, there's sort of the stripe of brighter white. That's a very thick buried valley through there. And we just don't see sinkholes there. If glacial material is about 25 feet or thicker, we tend to not see sinkholes. So again, this is the same extent showing where we do get a lot of sinkholes in the state. These 4 areas outlined in black are ones that we have finished our field work for, and I'm going to talk about those in some more detail. So as far as things we can measure on a sinkhole, so this here on the right is our DEM, which comes from LIDAR data, which Brittany is going to talk about a lot coming up, so I won't get into that. But in effect, you've got the outline of the sinkhole here, and from that outline, you can measure a number of values. So you can look at how deep it is, how far around, how much area it encompasses, and other things. These different shapes here show some of the different expressions sinkholes can have. Some are extremely circular, some are nearly lines, and others are very blobby. So let's talk about those 4 regions. So we have Bellevue in the north, Delaware, Springfield, and then Hillsborough in the south. So we looked at the shapes of sinkholes across these regions, and we noted that in the north, sinkholes are really big and very irregular. And in the south, they are generally very small and very circular. So here's just a quick overview of Bellevue. This is that area in the north. And just here, this is again the bedrock map. So just note that almost the entire collection of points here is on the Columbus limestone. So it's very limited to that. You get a little bit outside of that, you get into the shales, and you just don't see sinkholes. So Bellevue has very large sinkholes. We have one down here that's, it's more than a mile long in multiple directions. This is an enormous sinkhole, very irregularly shaped. Also, Bellevue is unique for its collapsed caves. This is the picture from the inside of Seneca Caverns. And as you're walking through this cave, if you ever make it up there, you'll note that the floor matches the ceiling. So it's thought that the rocks below this cave dissolved out and the floor collapsed. So if you were to lift it back up, it would kind of fit together like a puzzle. This is different from other parts of the state. This is another map of Bellevue, and you'll note there's sort of this, this shows the stream, this just superficial streams in Bellevue, and there's kind of an empty spot in the middle, and that's where all those sinkholes are. And Bellevue is kind of odd in the state because there's really no creeks on the surface. All of the drainage there just pretty much goes into the sinkholes. So here's a photo of a Bellevue sink. Again, it's enormous. Here it looks like a pond. It had rained a lot recently, so it was a little bit flooded out in this field. Now this photo on the left that we're looking at of the field is just that top little blob of the colorful DEM on the right, just that top little circle. So it's kind of hard to wrap your brain around how big some of these sinkholes up here are. All right, moving down to central Ohio to Delaware. Delaware is unique because the sinkholes tend to form these very linear patterns right along the rivers. And that's because as the river eroded through the glacial material, it resulted in the bedrock being slightly closer to the surface. So it was a little more exposed and you could see the sinkholes. Here is a nice photo of Olentangy Indian Caverns. It's completely different from the caves in Bellevue because this cave is solutional, so the passage is actually dissolved out instead of resulting from a collapse. Also, the sinkholes in Delaware are unique for being very deep and very linear. They tend to be long and narrow and surprisingly deep. Here's an example of sinkhole in Delaware. You note that there's a culvert draining into this sinkhole. So there's a neighborhood to the left of here, and all their drainage just goes down into the bedrock here, which is, unfortunately can cause a lot of erosion and tends to make sinkholes larger. That same sinkhole on the DEM, you can see it's quite long and linear. There's a line across here because there's a driveway that runs across there, but it's just has a culvert underneath of it. Here's another series of photos from Delaware. This is one of my favorite sinkholes in Delaware. This was in 2009, actually, before I started at the survey. They went and took a photo of it. And you can see that the sinkhole is very deep. The entire stream is draining into it. This continuation of the creek here just looks like forest. And note this diagonal tree here has actually just sort of landslided off the edge and into the sinkhole. So now we jump forward in time and note that this diagonal tree is still in here and the water level is higher. So it appears that this sinkhole isn't draining quite as effectively. It's sort of slowly filling in. You can see some water has overflown and gone on down the stream. Jump forward again another 2 years. It's filling in very quickly now. We still got the diagonal tree. It's getting pretty rotten at this point. Out to 2020, so almost to the present, and it's basically level with the surface. You'd almost never know there was a sinkhole here. The water still does drain into the ground here, unless it's flooding, but it's changed quite a lot. The diagonal tree is still just barely visible here. There's really not much left at this point. All right, moving on to Springfield. So it's a little bit south and west of where we were in Delaware in central Ohio. Springfield has generally small sinkholes, but significant. They have some very quick water transport times. The water moves through the ground very quickly, as it does in all karst areas. Some of the reasons that Springfield has less sinkholes is because it has very thick glacial materials. So a lot of the bedrock that would be forming sinkholes is just deeply buried. Just a small example sinkhole here in the photo. All right, jumping down to Hillsboro in south central. This is really Highland and Adams County, but focused on the Hillsboro area, just the area in this black rectangle for the comparison to other regions, but the trends do continue south of here. So in Hillsboro, there are many small circular sinkholes, and it also has the most total sinkholes. So if you look at, individual sinkholes, Hillsboro has the most. If you look at the size of sinkholes, Bellevue up in north central Ohio has the most area covered. And we have Andy here in a classic sinkhole in Hillsboro. So again, small circular sinkholes in Hillsboro, they tend to be very clustered, especially along the edges of valleys, kind of just up on the break of the slope. So you'll have an area with no sinkholes, with fields up top, often forested strips with sinkholes, and then the stream valleys down below. Another example sinkhole in Hillsboro. And this is one of my favorite sinkholes in Hillsboro. We refer to this one as the chasm. It was quite unexpected to find it. It's quite deep. Brittany will have to confirm this. I think it was 15 feet deep, and we didn't know it was going to be there. Just sort of popped out of the woods. But it was cool. You can see the solution to bedrock along the sides of it. All right, so those are our 4 main areas of the state that we have compared the shapes of sinkholes in Ohio. Just real quick, here's a map that shows where some of the public caves are in Ohio. So Ohio has many caves, hundreds of caves, although a lot of them are small, known colloquially as twilight caves because, you know, many of them don't go into true darkness, and few of them are open to the public. But there are some that are open to the public, and we've looked at some photos of those today. So I think at that point I'll turn it over to Brittany.
Okay, I believe you can see me and you can hear me. All right, so as Douglas said, I am going to talk a little bit on the kind of fieldwork side of things. So how we locate these sinkholes is sort of a multi-step effort. So historically, it was kind of using the topological quiet triangles and looking at soil maps. When I started, a bunch of areas that we hadn't studied yet had, you know, points that people doing soil surveys had noted, and they would say, hey, there's a sinkhole here, and that was kind of the data set that we had established going in. And that was a good place to start, definitely. And then we also used aerial photography of an area, just kind of, we can pick some things out visually, but it's not nearly as good as, you know, using the LIDAR and the DEM, as Douglas mentioned, I will talk about in a second. And then kind of the cream of the crop is the field checking. And the reason that we do this is because we can locate sinks that are newer than our elevation data. We can locate sinks that are smaller than the elevation data can find. And then also it gets us out and we're able to talk to landowners. And when we get out and do that, they can tell us some historical data about the sinkholes that they have. We can get out, some of them will be like, hey, I have a bunch over here that you don't have on your map, and they'll show us around, or they'll tell us we've been filling this sinkhole up for 30 years, or I lost a tractor down there in the 80s. Different things like that that, you know, go into our data set that are just super interesting to hear about. So I'm going to focus on this area in Peebles, Ohio. I know that's not an area Douglas talked about, but Peebles is so far my favorite. So here is the topo map of an area in Peebles. And the cool thing about this is that this line here, when the lines point in, that means that is the way the land dips. So even on the topo map, we are getting a little bit of, you know, depressions forming. So we have this kind of big one here, we have a little one over here, bigger, and then kind of off the screen is this very large blobby sinkhole looking guy. And that's kind of what Peebles is a little, I mean, famous to us for, because it is a very sunken area. The aerial imagery of this same field in Peebles, and right off the bat, this is a couple things that would just jump out to me. Kind of standard areas in, you know, the south central portion of the state. If you have a tree in the middle of a field, some might be a sinkhole, might be worth looking at. So immediately these lonely trees pop out. And I know sometimes trees left in fields are a form of, you know, seen as good luck to different farmers, but sometimes I think sinkholes. And you can also see like little bits of brushy area, things that just, you could tell they've mowed around, and that's definitely the biggest indicator. They don't want to drive over it because they might sink into it. And then if you could see down here in the kind of bottom left corner, there's a bunch of little kind of dug out things, and those most likely are cow wallows, but let's take a look at the DEM. So this is the elevation data that we have for the state, and it is processed from the LIDAR, which I'll talk about in a second. But as you can see, there is a lot of very little depressions that show up on the DEM that are not available or really notable on the aerial or on the topographic map. The topographic one showed kind of this big outline thing here, and that's, we just call it the Peebles sink because it's very large. And then you see a bunch of little things that show up that, you know, are on the topo, might have been visible on the aerial, but it kind of depends because our DEM data can be older than the aerial. So it's a back and forth thing between, can we find it on the aerial if it's not on the DEM? So the way that we use all of this together, the biggest thing is definitely the LIDAR. That means light distance and ranging. And what that is in 2006, they flew the entire state with an airplane, shot a laser at the ground. And when that laser returned, that was when the times between that was how they were able to determine, you know, the topography of the state. So it sees through trees, different kind of like things that would get in your way, like aerial. You know, if you have a forest, you're not gonna be able to see through the trees to see sinkholes. So it's really great to be used that way. The issue is that it was done in 2006, so it's pretty old at this point, and we tend to find a lot more things than it has data for. So that's when we also use the imagery. Right now we're working with 2021 imagery, sometimes older, but now we're getting updated things, and it's very awesome. And soon we will have updated LIDAR, so we'll be able to go through and see just how many things are picked up versus what we saw, which is going to be very cool to me. So to process the LIDAR, this is where the bulk of the office work comes in. So here's the same area in Peoples. What we do is we take that elevation, that DEM, and we fill it in. Like say you just have a cup and you fill it with water. Then we take the cup away. So we subtract the DEM from that filled depression. It kind of creates a smooth surface, and then we'll remove, you know, to get a relief of just the depressions. They are then reclassified so we can have equal intervals for the depths. And then we take that goofy looking raster. I didn't show you pictures because it's just a mess. And then we convert it into polygons. And once we have polygons, that's when we can get in and really start editing. So we have another model that we run that's actually really helped us clean up the data a lot faster. We're talking millions and millions of polygons because it creates, it shows every minute depression possible, and I'll show you in a second here. So we have got a model that will remove polygons that are very small and all by themselves that most likely are not a sinkhole because they're too small for the DEM to have actually registered. So we're gonna go back to this area in Peoples. And then I'm going to show you, we're going to jump between the DEM, kind of jump around. So we filled it in, and this is what it looks like. This is a lot, right? Okay, so the red is the deeper, and yellow is more shallow. And then you can see in some points where it goes back to the yellow. That's because it's gone too deep for the original spectrum to kind of, you know, reconcile. So before, you know, we had been looking at the trees and these different depressions. So the trees look like they have depressions. That's good. That makes me feel nice about my aerial, you know, assessment. But then you'll notice that some of these like cow wallow things didn't have anything. And like I said earlier, that could be because the data is from 2006 and the imagery is from 2017 or 2021. It doesn't mean they're not there. It just means we can't capture them this way. And then hard to see down here, but this is a pond, and I know that that did produce some sort of depression, and that's another reason we go out, is so we can kind of figure out what is a sinkhole and isn't a sinkhole. So this is, and then we have all of these little things, just little blips of polygons taking up space that are just too small to even be considered sinkholes. And then we have, you know, stuff over here with the streams, different ditches, kind of a culvert situation here with the railroad tracks and a road, things like that we have to eliminate and assess and think like that's likely not a sinkhole. We have kind of a ranking where we think, hey, this is probably a sinkhole. We feel good about going to it. And then we have a maybe where we're like, it could be a sinkhole, it could not be. If you're nearby, we should go check it out. And this is after everything's cleaned up. So we've just kind of eliminated all of the things, you know, the debris of polygons in the different corners. And this is what we put on, you know, our field collector to go out and look for. And then after we finished going out to this field in Peoples and walking around and looking for sinkholes, these are all the points that we had. So as you can see, we have points on many of the depressions, or all of the depressions. And then points that are not on the depressions. That's because these are all things that the DEM couldn't pick up. So either they were newer or they were too small, which means this area has been at least somewhat active since 2006. And I think kind of the average right now for, you know, the percent of points that we have that are new to us entirely is about 30 to 40%, depending on the region. So that's a super cool information for me. That number blows me away every time, especially considering we'll go to one place and we'll stand in a sinkhole and I'll be like, there's more over there. And it's just a constant bebopping around looking for all of these depressions. And then this is what it looks like without. So you can see, you know, this one tree here actually had two other sinkholes kind of adjacent to it. It could have been just plain throats, just an open hole. or it could have been its own separate depression. Sometimes you'll get these nested depressions where one's deeper than they kind of sit on the outskirts of it. So it's very cool to go out and be able to verify and find more. And then the reason, like the big reason we do this is because so many things can look like sinkholes that aren't. So as I showed in the other slide with the different culverts under roads can look like something. So we know that looks like that. That's pretty suspicious, excuse me. But also sometimes, I mean, that's not going to stop a sinkhole from forming in a culvert or in a stream. So that is something that we try to eliminate in office and then also in the field. And then this picture shows kind of a dammed pond. So you can see here is the dam because it's a little bit higher than the water of the on DEM. And this is kind of like the weird fractal looking is when it hits water sometimes and it just doesn't bounce back right. So we try to eliminate that, different storm drains, foundations, ponds. I know a big problem for Douglas when he was doing Bellevue work was field tile, because up there they want to be able to drain their fields, and when the field tile collapses, it does look like depressions and sinkholes. And then I took this picture on the left here a couple weeks ago when I was out in near Piqua. I was doing different Tormino data, seismic data collection, and I found this very deep failed to drain tile, and I was like, this is crazy looking, so I took a picture and I sent it to Douglas. And also we find some foundations that can look like sinkholes, but they're actually not. This is down in Claremont County. As you can see here, this is kind of what the blip on the LIDAR looked like. I believe we had another point there, and that's why we went, because sometimes the way that the DEM kind of forms itself, it kind of looks like a hill, but it kind of also looks like a depression. And as you can see, this picture on the right here is the foundation that it was. So it tricks us still sometimes. And then ponds can be very hit or miss. It depends on the region, really. So the picture on the left is a point we had gone to check out, and we went there and it was a pond, but then there was bedrock at the bottom, as you can see right here, and all of the water had drained through the bedrock. So it was a sinkhole at that point. But you could see there's a dock and there's kind of like a little bit of riprap over here. People had wanted this to be a sinkhole, and it clearly, a pond, and it did not want to be. And then the picture on the right is where we had a sinkhole, and then Douglas was talking to the landowner, and this is great historical data, that it was a sinkhole, and they ran their cows through it, and just all of this constant stamping from their hooves was able to clog it up. We've heard that from numerous people. People run their pigs through, cows, anything that just kind of just stamps all the mud and grit down there can actually clog up some sinkholes pretty nicely. Another great perk of the field verification is that we can find springs. Excuse me. As they are right now, we can't really find them on the DEM because they don't create a depression like a sinkhole would. Sometimes we can try to pick where we think they might be coming out if it looks like a ridge has a random kind of drainage slippery slope look to it. But more often than not, we find out from landowners where they have where they have springs, or we just stumble across them in our field verification process. So this one on the left here is in a stream bed that we were just walking down to get to other sinkholes. We kind of walked along it. We're admiring the karst features and just kind of picking out where the water was coming out of the hillside and joining the stream, which is super neat. And then the one on the right is similar enough. This is actually within a larger sinkhole, and then at the head of it was just a little spring burbling out water, and I'm down there taking a look. See, it's kind of a little recessed twilight cave, but it wasn't very deep or anything. So the field verification process is all well and good, except for how we collect the data. Normally we use an iPad, go out. We have ARCGIS has a collector or field maps app that we can use. It's super great. I took these on my phone because recently I've just been using my phone because it's a lot easier to carry around, easier to charge, and it's just kind of easier to handle also. So here we have people's area. So this is what our map would look like when we go out in the field. We break everything up into these 2 kilometer tiles. That's just kind of our way of staying organized. So when we finish all the points in that area, we can mark the tile down and know that we don't have to go back to this area. It's just organizational for us. So here's this area that we've been looking at up close. You can see it's right in Peebles. You know, you zoom in, you have, you know, your direction, this is like the different layers you have. This is the point. If I select one, I did this at home, so I'm 72 miles from it, but, and this is the fields that we can show when we bring up what we want to edit. So we go in, we program some things. So we program, when we can, the bedrock unit that it is, but then we go in and we select what type of point it is. So it starts out as a field check, and then we change it to verified or not karst or whatever we think it is. We'll take a picture of it if it's especially great. That's Douglas's purview. Show when we visited if it was field added, different comments, you know, if there's bedrock, if there, you know, length, width, depth, if there's fill material, just to kind of try to organize all of our data for these sinkholes. Excuse me. And the really cool feature about ARC field maps that I've been using recently is that you can now navigate to different lat longs within the app. And before it's kind of, I'm driving and Douglas is going, okay, turn left. And I'm like, okay, I will turn left at the next left. There's a lot of times where I don't want to stop too fast, and it's a little difficult to navigate when you're just looking at the aerial. So this is really nice. It's going to make our job a lot easier going forward. And then also we can load in the polygons that are associated with our office processing. So this is down in Cincinnati, which we did last year in Winton Woods. This is a big old sinkhole here, and it's actually pretty broad and a little bit flat in the bottom. So here on the right is me standing in it. But it's just nice to be able to go out there. We know kind of what we're looking for, have the polygons, have the points, and then we just navigate via the phone or the iPad. So now I'm going to take this time to talk about a couple of my favorite sinkholes. A few, I have 3. Everyone that knows me with survey knows that I love this sinkhole. I have named him Harold. This one was particularly striking to me for a couple reasons. So as you can see in this map in the left, before we went to this spot, we only had this one sinkhole to go investigate, because we're kind of like, okay, that looks like there might be something going on here, but we have at least one point. We're gonna go look at it. And we're just walking through this empty field, walk over a rise, and just this hole appears before me. That was, in 2015, I'd been at the survey for about 1.5 years, maybe 2 years, so I was very impressed with this incredible looking sinkhole. And we've been going back every couple of years to kind of just get the same measurement of it. See if it's getting bigger, if it's gotten longer, deeper, whatever. So we revisited in 2017 and 2019, and it's gotten 1 foot deeper and 6 feet wider. So it was kind of neat to be able to go through and see all of the different changes, how kind of the bowl that I'm standing in has a very whirlpool effect look to it sometimes. Like it fills up with water, but then drains. Here's another picture of Harold. I think that was actually maybe 2017 there. And then we have this is a PHOTOMOSAIC thing that Douglas did that is absolutely fantastic. He took 417 photos of Harold and was able to compile them in a separate program to create sort of a 3D image. And I know, Douglas, before you had a video. Is it a video now or is it just a still? It's not working for me.
I think if you just go to the next slide.
Oh. Ah. So yeah, this is it. You know, accounts. You can see the vegetation. You can see the hole down here. This is kind of like the slope to come in. It is such a neat thing. But we did stand there for a very long time for Douglas to take all of those pictures. But I didn't mind. I love being out there. This next one is less of a sinkhole and more of a void. This was when I was out in the field with another coworker, Nate, and I was standing in one sinkhole literally 5 feet to the right of it. And he turns around and is like, oh, hey, what about this? And I'm like, oh, okay, that's not here. And I looked in and I'm like, oh, all right, it's a hole into nothing. Cool. Let's, be careful where we're standing. We don't want to stand where there's no rock or, just in case. We haven't fallen in yet. So I pull out our plumb, which is basically just a weight on the end of a string that we've knotted every 2 feet so we know the depth. It's very scientific. So I throw that in the sinkhole and I hit, as you can see in the picture, like that I'm gesturing, the end of the plumb. That was 43 feet deep, and that's why we call it crazy deep, or I call it crazy deep. I did end up losing the plumb down there. Apparently the knots for every 2 feet also make great nick points for rocks to catch and chew up. So somewhere down there is my favorite plumb. And it was very neat. We did spend a minute the first time we were there tossing rocks down to try to count just, you know, how far it took them. And it sounded like some of them went kind of sideways. There might be, you know, a very voluptuous fracture down there. Not sure. And the last one I will talk about is one that we call upside down garden hat. This for us was a completely new point, but then we were actually able to see it on the aerial. That was really neat. And the thing about this is that it likely started out as a cow wall. It just kind of had that look like, you know, cows are rolling in it and doing whatever. And then just like middle collapse, because when we go back on the historical imagery in Google Earth, you can see where it's been developing. It doesn't have the big hole in the bottom like it does in this picture, but it's there. So it was really neat to kind of go back and see that from everything. So now I'm going to show you guys the interactive map. I'm going to give you a little tour of that. Give me a minute here. Where are you, interactive map? Here we are. Okay. So this is the interactive map. I think Chuck or JD will link it in the Q&A or in the chat or something, and then you guys can go and check it out yourself. This pops up right away, disclaimer, kind of information about the map. It'll give you kind of our vocabulary that we use, and this is how you download the data. But this shows, and it's updated very regularly, this shows all of the sinkholes that we have mapped and hope to map. So here are the areas that Douglas was talking about. You've got Bellevue, kind of Springfield for Champaign County, Delaware, Franklin, and this is the south central portion of, you know, Highland, Adams County. So let's kind of keep going in. We'll take you right to, oh, not right, there we go. Right to that field. Here we are. And then you can click on all of these different points. It'll pop up. You can get some, you know, the data that we put in for it. If a photo is there, you can look at the photo. So yeah, it's a sinkhole. It's pretty basic. Some of them have lots of photos, and that usually means we were pretty excited about it, and it needed a lot of photos to be taken of it. But otherwise, it's kind of really fun to play around in, and it's you have different layers up here that you can add, so you can throw in the bedrock geology to see, you know, what unit you're in geologically, and then also analyze the drift thickness as well. And you can easily put in coordinates for any place that you would like to know about if you think that there might be a sinkhole there. It's really great. I know we use it pretty much every day. And then I will go ahead and go back to, sorry about the flipping back and forth there, guys, but I wanted to get it. We'll go ahead and give the summary. So as we were talking about, karst mostly occurs in carbonates in Ohio. There are some hazards associated with them. It's not like Florida. Your house is not going to get eaten with you in it, hopefully. Very different types of sinkholes depending on the region that you're in. We hope to do more analysis on that in the future as we continue mapping. LIDAR is our very best friend. Without it, we would not be able to do nearly as much as we are now. Field work, I think, is most valuable because it confirms the sinks, and I love being out there. And you can look up all of our data on the Karst interactive map, or you can email Douglas or I if you have any questions. And then now we will actually, I think, if you guys have questions for us.
Yeah. Well, thank you so much, Douglas. Thank you, Brittany. We do have some questions. I'm going to toss the first one out here and post this here. The first question comes from Robbie. Robbie asks, if you fill in a sinkhole with concrete or boulders, does that harm the soil, the environment, or does it help with kind of stopping the growth of the sinkhole?
I'm happy to take that one. Yeah, so in general, concrete or boulders is okay environmentally because it's you know, they're stable materials, so they're not going to really hurt the ground. But it can be a bit of a problem in some ways. Sometimes concrete can plug a sinkhole, and that can cause some flooding. Sometimes the weight of all the rocks or concrete can actually make the sinkhole sink more than it otherwise would. So often, as far as fixing sinkholes, your best bet is to, ideally dig it out down to rock, fill it up with bigger rocks at the bottom, then finer rocks going up, and then you put some fabric across that'll let water through but trap the soil, and then cover it up. So that way it can still drain, but it's not eroding.
All right, next question here can it be dangerous to be so close to some of these sinkholes? What precautions do you take to make sure you're safe when you're in the field?
We go out in pairs. We don't go out alone. There's definitely that. We just, try to just be cautious around the edge of them. If it looks like it's had a lot of activity, if the edge of the sinkhole are very eroded and there's no soil growing on it, just keep our distance, really. Don't go hopping down the bottom of them in case, there's no bottom to them. But otherwise, it's just, at this point, we know that they're holes and they might swallow us, so we're pretty cautious.
And many sinkhole, what you see in a lot of these photos are the most active sinkholes. Vast majority of sinkholes in Ohio, are low and shallow and not, not super dangerous.
How do sinkholes in Ohio differ from those I hear about in Florida? That's the next question here.
You mean take that one? Yeah, so in Florida has, their sinkholes also form in limestone, just like ours, but the material that covers the limestone is largely sand. And sand just doesn't hold together well. Most of our rock is covered by a till, which is a mixture of clay, sand, and silt, but it tends to be very sticky. So it tends to hold up a lot more than the cover down in Florida does. Their karst is also more developed than in Ohio. They, since their groundwater is exposed to seawater is very effective at causing karst formation.
Thank you. Then I have a couple more questions here. If you all have any other questions, feel free to put them in the Q&A and we'll try to get to them here before time runs out. The next one we have here is, how fast does karst form and how fast do sinkholes form? And, I might add to that, are those necessarily the same thing?
Sure. So we think that a lot of the karst, as far as the actual dissolved bedrock in the state, we think a lot of that may be quite old, and possibly may predate the glaciers. So, the bedrock may have dissolved majority of the way it is now. There's probably still some forming all the time as water moves through the system, but, most of that just, dissolving rocks takes a very long time. Now, sinkholes, that can be in a bit shorter time, especially as groundwater flow on the surface changes. If someone builds a pond in an area that has buried fractures, that water pressure can cause sinkholes to form because there's so much weight pushing on the ground, for example. But as far as the actual timing of sinkholes, it's poorly understood. Some of them can form, in years or less. Some take much longer than that.
There's a question here that basically, I'll summarize it by basically saying, should you drink from springs? Is it safe to drink from springs that you find, emerging from the ground in karst-prone areas?
You want to take that one, Brittany?
In karst-prone areas, I would hesitate just because of all the things that we have found in sinkholes. And as Douglas said, they are a direct conduit to your water table and your water system. So that gives me pause. But I know I've drank from springs before that are not in karst areas. So it depends. I would not advise that. Maybe bring a life straw.
Yeah, if it's a spring that's new to you, it's probably a good idea to get it tested. It's not expensive to do.
We just had another question come in from Greg. Greg asks, are there plans to use geophysical methods to connect sinkholes? So
we have done a little bit of geophysics on sinkholes in the Delaware area around the Olentangy Indian Caverns, and we have we believe we've shown that some of the sinkholes at the surface that don't have caves underneath of them probably do have caves. They're just not connected to the to the known cave. It's very time consuming to try to do that kind of study on a wide scale. The reality of it is that we have large areas of the state that we haven't even finished this process for, but geophysics can be of great help for sure.
A little bit of a silly question here for Brittany. Do you have any plans to visit Harold, your favorite sinkhole, in 2021? Or I guess I'll add to that, or kind of tweak that. What are your upcoming Karst plans for the next year or two, just kind of in general?
Oh yeah, that's great. I stopped sharing the screen, but we tried to wrap up kind of some close to home stuff in this past year when we were allowed to start going back out. Doing a little bit in Franklin County and wrapping up some stuff in Delaware that was inaccessible in 2011. But next couple of years, I know Douglas has been processing a little bit of Brown County. We have the rest of Adams County that looks absolutely delightful to do field work for. I am very excited for that, just because it's going to be more discovery of very crazy things. It's a very dynamic environment down there. And I will say for Harold, I think about it pretty consistently, just thinking, well, while I'm in the area, I could just pop by. But I think if we get back to field work in that area, it's not out of the question to go and see if the measurements have changed at all.
All right. I have one final question here, unless another one sneaks in at the last minute. The last question is, Douglas, you mentioned getting water tested. How might one go about doing that? Would that be Ohio EPA?
Yeah, I would say, yeah, EPA or the county health department, I think is generally able to do that, or the city, whoever the city water folks are, depending on the area.
You direct them to the EPA or their local county health department or their water provider to answer that question. Great. Well, I think that's all the questions. So thank you, Douglas and Brittany, again. We're going to be taking this webinar, and it will be on the ODNR YouTube channel. You can look under the geology category to catch this sometime in the next coming weeks. And I think there's been some requests to have maybe a copy of this presentation put somewhere, so we might link to that from the YouTube channel, or check out our social media and our website, geology.ohiodnr.gov, and we'll have some ways for you to follow up and revisit everything we've learned today about caves and karst in Ohio. And I also encourage you to check the links that Chuck has posted over in the chat, the links to the interactive map that Brittany showed off today, as well as our online karst reporting form can all be found there. So if you all have any other questions, don't hesitate to reach out. I'm sure Douglas and Brittany would love to hear from you. Thank you all very much for tuning in.
All right. Thank you.
Thanks, folks.